Alright, hello everyone. First stream in 2 years. This is exciting. Um, Probably won't be super long. Okay, stop just sending single letters in the chat. I need to know your, Oh, okay. ASA, yeah. It's pronounced ASA, by the way. That's the programming language's name. So I'm probably gonna first start off just talking about, like, what it is. And also how the compiler is going. I only really have a tokenizer and an AST generator, but yeah, we're probably gonna just finish up the AST generator and work on some optimizations today. Not really get into actual compilation or running code. But yeah. Also, tell me if the volume is too loud or too quiet, or the music is too loud. All my settings aren't the same as they were 2 years ago when I last streamed. Actually, this is loud for me, even. Right. Alright, so this is basically an example program. It's, relatively inspired by Jai, which is John Blow's language, because for some reason I just got into watching all of his talks, and I kind of felt inspired to make something of my own that follows sort of a similar standard, fixes a lot of the problems he talks about. Although I do have some differing preferences, so some things are different. So there's like module importing, this is how it works. And you can also include files, but, that's probably not going to be the standard way of including things. This is like a main function, you just do the name for the identifier, ::, that's like compiler equals, and then you can place a type like int here, and then that's the return type, but you don't need that for the main function if you don't want. It can be a void type. And then the arguments, I haven't really decided if they should be the exact same as C++, but currently this is what it is. I could make them also be like that, to follow a similar sort of definition as the functions. But I don't know, it seems sort of... it repeats too much, I think, in my opinion, but maybe not. I don't really have much for example code. It's really just basic programs, and then I'll sort of figure it out as I go. I have another program actually here. So syntax C++. So this one is basically a function redefinition at runtime. So basically you call test redefined function, which is called from here. And you have the function called test function, and it prints this out. But then you can also redefine it to be equal to this other function at runtime. So it basically is a function pointer by default, without having to define it as a function pointer. I'm going to have types be inferred by default, and then you can set the type. Again, the types, how they're defined and how their type is set is still kind of up for debate. It's going to be the same as it is for the functions. So if I keep it as it is down here, then it's going to be like int I. But it might also make more sense to do that. I'm not super sure. Another thing that's in Jai that I really wanted to be in this language that I thought was an absolute game changer was compile time execution. So basically I can type run and then multiply. Oh, that is a typo. Actually, let's do main. This won't execute, it's just pseudocode essentially, but when this compiles, it will run main, and then all of this code will, it'll happen, and yeah, this is super useful. I wish I had a demo to show you, but you can essentially do tests and code generation and everything like that with just one command, the compile command. And also, it's super important that this language does not need any external build tools, so you don't need to make like a bash script or something for manually building, because it should be super simple. And also, you should be able to use this language as its own scripting language. So you could run a single command like compile main.asa, and then that may call a run build during compilation. It creates all of the resources necessary and just completely compiles your program. Yeah, so let's see. I'm going to... okay, so this is the code on the right that we were just looking at. And let's see, where was I last? I'm going to show what the AST output currently looks like. Am I creating it from scratch? Yes, I'm creating it from scratch. I mean, it would make sense to like incorporate LLVM at some point because of optimizations and stuff. Oh, sorry. But currently, everything that I have now is made from scratch. db/asa run start main.asa. Alright. My plans for the stream are basically I'm going to explain well, I already just sort of explained what the language was. Probably could get more into that, but then after I'm going to just talk about what I've written so far, and yeah. After all that, I'm going to see if I can just finish building the AST generator and also optimize it, or create an optimizer. The AST generator is not optimized. So basically, it steps through the program. Well, first it tokenizes it. So, for example, oh, actually, it also outputs the tokens, so I can just go up here. There's a lot of output. Alright, so it turns it into a whole bunch of tokens. So it'll like get symbols or entire strings or literals, identifiers. So it gets hash here, import, and then the string that's import basic/print, and then semicolon. And it does that for the entire file. And it tries to sort of infer what this symbol is for. And it does that by looking in a lookup table. Well, hold on, I'll show you. So basically, This function called tokenize is run on the entire file. The entire file is just sent as a string to this function. It starts making the tokens by looking at the current character, the previous character, and the next character. And it looks to see if the current character is the beginning of a character in token starts. So basically an identifier, it starts with letters or an underscore. That's just how an identifier is identified. Numbers, just numbers. Strings always start with a quote symbol. Punctuation, that's just all the different symbols. End of line, and nothing is just a space and a tab character. Right now it's only ASCII. That should change in the future when I want to get around to it, so that it works with Unicode. Just because, I mean, if your language doesn't work with Unicode in 2025, that's kind of insane. And then down here, these are token escapes. So basically, it'll start a token, and it'll keep adding characters to that token until it reaches one of these escape characters. So an identifier will end if there's a space, or if there's any other symbol that's not a letter. And, a number, same thing. A string will end when another quote character is reached. This doesn't work for escaped quotes yet. I should add that functionality. Should be pretty easy, but I don't feel like doing that right now. So yeah, that's basically how the token system works. And then after all the tokens are created, it steps through each of the tokens, and then it runs the program generate AST, which is a recursive function which creates AST nodes. AST stands for Abstract Syntax Tree. It's basically just a super simplified version of the syntax, so the computer can understand it better. And it looks at the token type, and if the token type is, for example, an if statement, it will start generating an if statement node. So if I go down here where there's an if statement, it creates this if statement node. And an if statement node needs to have a condition node and a body. If the condition is true, then the body is executed. Basically, just, yeah. Then the body, there's a function call inside of the body of this if statement, and this function call needs to have arguments, and the arguments are expressions which need to be evaluated, and this expression is just a string. So, yeah. For the most part, I have things implemented. I'm not sure why these are marked as unused. That might be an issue I want to fix. Let's see. Yeah, I think I need to have a check for semicolon so that this leaf node is used. Oh, that's right. Okay, so basically it adds all sort of expressions to a unused leaf node vector, which will be used later on if, an expression needs to be evaluated. So for example, this I equals, it'll add this in parentheses to the unused leaf node vector, and then when it reaches this minus, it'll pop off the end of that vector, and this will be used in this expression. But for example, in print, this function call, it's never actually used as a term in an expression. So it just needs to be called without using its return value. Yeah, it's essentially just like a return value check. Let's see. And don't mind the AST code. It's really long, needlessly so. Basically, each of these have quite a bit of repeat code for gathering all the tokens necessary for like the bodies and what's in parentheses and etc. Semicolon. I already added this, but I think the reason I added it, the use case doesn't exist anymore. So I need to make sure this still applies for what I need. That might work. Basically, this checks to see if it's a semicolon, then any leaf node should just be added as normal child nodes. Yeah. So let's see if that works. Compile. It looks like it works. Yep, print function call, that got moved up here. Yeah, that looks good to me. Sorry, I was just checking the stream to make sure the quality was okay. If any of you have like questions on, well, anything, feel free to ask them, like the mine link or I don't know, any videos since the last 2 years I've streamed. Alright, so now for the AST, I want to essentially just optimize it. It sort of generates, like, literally what is there. So, like, if I say I is equal to this entire expression, it literally creates that entire expression. Let's see, where is that one? So this is that expression. This equals, it's I equals this entire expression. And then it does minus, you know, all of these operations. But the thing is that obviously these are all constants. And it's really not necessary to evaluate the value of this expression every single time it runs. So I'm basically going to simplify the AST node so that only the final value, or the simplest value, of this expression is actually put in the AST. I'm trying to think how I should do that. Let's see. Optimize AST node, and this also needs to be a recursive function. a bottom-up recursive function, so it needs to go through all of the child nodes and see if they are expressions. Yeah. AST node pointer, node. And I want to loop through, so int 0. Oh wow, okay, I'm missing all the keys. And node, what are they called? Child nodes? Okay. Child nodes XS. Yeah, and then for each of the child nodes, I want to run this function again until it has no child nodes. So I don't have to have an if statement or anything. I can just, yeah, I can just run the function. Optimize next node. Child nodes I. So I think I have a map that I can use to check if it is an expression. So I can do like node.nodeType. The ASA language is intended to be used for, you know, that's a good point. I really don't. Honestly, I want it to replace C++. That's basically my goal. I'm writing this entire language in C++, but really, the process of writing a program in C++ is not that enjoyable. I've been using it for maybe like 4 or 5 years now. And I made some really cool stuff in it, but it kind of sucks. I waste so much time, like, just dealing with the compiler. Really, the language is too old. It's kind of made for a time that there were, like, more limitations that needed to be worked around, and now the compiler sort of just still acts like those exist for no good reason other than backwards compatibility. And I guess it's not really uncommon to say it's bloated. I guess like the simplest answer is that, I mean, making apps, I guess, or games. I'm a game development YouTuber that makes games in interesting ways. Yeah, I haven't made a game in C++ in, well, probably ever. No, early on I think I used SCL2. Other than that, it's mostly just apps or simulations. Unless technically Z#. I wrote a game in C#, which was written in C++. So by proxy, it's C++. So I can use an if statement on this specific node. So if the node.nodeType. Oh no, if operator precedence. Yeah, I think I have a map called operator precedence. So I can just check to see if the operator is, or if the node type is in operator precedence, because then it'll be an operator. So let's, if operator precedence dot find node type, is equal to operator precedence dot end. Nope, if it's not equal to. Yeah, so if it's in that. I don't normally program this slowly, trust me, guys. So I think I should create a secondary map that contains all literal types, so like string literal, int literal, and I should probably create a float literal as well. I don't think that even exists. Yeah, so I guess I'll do that. AST node type. Okay, well, using a map is probably wrong, but you know what? I'll leave that for future me. Whatever. Int, I guess. Literal map. This is this is terrible. This is some of the worst code I've ever written. Shoot. What are these even called? These splits. Number node. I kind of treat all numbers as the exact same when they probably shouldn't be. Whatever. Oops. Number node. Boolean. So I guess I'll do a secondary check. Wait, so then this one is if operator. Well, actually, this is only for binary operators. Yeah, I don't think I have any. Whatever, I'll leave it to future me. Oh, shoot. AST node. Pointer first and then second, I guess. Is equal to node child node. I need to add a check before this, don't I? So if node child node dot size It's equal to 2, greater than equal to, I don't know. Child nodes 0, and second should be 1. I think I sort of need part of the compiler done in order to actually do this. Let's see. Will I rewrite the ASA compiler in ASA? You know, that's probably like the best goal you can have, to be able to rewrite your own compiler in your own language. You know, I hope it gets to that point, right? But I can't guarantee it. It's gonna be better than Z#, that's for sure. That language in quotes was a mess, needless to say, but the functionality will be there in ASA, but it might be difficult for a while. Just because, I mean, C++ has a lot of features, so... And not to mention, I need to write the, like the standard library and stuff like that. Alright, so I'm trying to think basically right now, how to actually evaluate the expression in this node tree. Because right now, these token values are just stored as... Yeah, so currently they're just stored as strings. So I'm gonna have to replace number node with an integer node and a floating point node. And then that way I can do conversion from strings to floats and integers, and then I can evaluate the expressions. Okay, got it. Gotta think through that one a little bit. Let's go up here. So get rid of number node. Make it... Or should I keep number node and then just like post-process it? No, I should pre-process it. Integer node and floating point. No, just float node. Float down here. My current system for printing out node types is just using an array of strings that match the enum. Which probably is not very good, because if it's just one off, it will completely mess up everything. Oh, I did that wrong. Integer. So I think inside of the tokenizer, really, I should do that. And that's 7. Let's create like a float type, like 4.6 there, and just make sure that that is just, you know, one number. Compile first. Or let's not compile first. Let's just see how it was running. Equals, no, that's the wrong equals. 4.6, yeah, that's just a number node, and let's go up to where the token is printed out. 4.6 number, okay, yeah, so it works. Neat. Probably didn't have to test that much, but whatever. Parse.c++, 56. Right, so that has the number type. Just change that to then the integer and the float type. So I think I'll start with the number type and then post-process to float and int. Wait, did I do float and int or int and float? Int and float, okay. I think I have a map. Yeah, okay, so if this and following character immediately end. No. Token escape canceled. I might need to implement a second or another map. So basically it's if the token type is number and it contains a dot, then it'll be changed to a float. Otherwise, it'll be changed to an int. Oh wait, then don't I just need the integer type? Yeah, I don't need the number type anymore. I can just assume that it's an integer by default, and then I can switch it to float if it contains a dot. It's probably the easiest way to do it. Number. So integer will just contain both of them. Yeah. I do want it to sort of have some lower level features. I mean, yeah, I'm trying to replace C++, so it's not going to be like much higher level, really. I want it to be like the same sort of level with system access. I don't even know what this map is used for anymore. Force is turn. Oh, it's used for the range type. I don't know if I mentioned it. So basically, this is how like a for loop, for example, works. Basically, you have this part, which is a range type. It's basically an identifier or a constant followed by 2 dots, and then another identifier or a constant. And then the for loop automatically can iterate through just that. So it's like super simple, basically. It's not any of the kind of stupid nonsense that is this in C++. Int I is equal to 0, I is less than 100, I plus plus. Like, that's kind of nonsense, right? It's weird too, like syntactically, because you're basically putting expressions separated by semicolons inside of a for. Right? It's just kind of weird to me, right? So by default, you just put any range type. And I'm not entirely sure how I want that to be handled for like array types or lists or whatever. There's probably going to be some sort of automatic cast, I guess, to a range type. So, for example, if you have like a list L. Okay, I honestly haven't even thought about how to define lists, but let's just do that, and it's of length 100, right? Oh, L. I want to be able to do this, or L, and then that just iterates through each element inside of L, and then obviously you can do for like I colon L, and then I will be equal to, well, it's sort of still debated also in my head, like, should I be equal to the element that's being referenced on this iteration, or should it be equal to like an iterator, so that you can do L at element I? I'm not super sure about that. But, you know, then again, most languages also have for each, which can do that. So I might just create for as the one where iterator is created, and for each as the one where like an object of the type is created. So L element colon L, and then it'll just basically be the exact same syntax, but the only difference is between the iterator and the element being referenced. Yeah, that's probably the way that I'll do it. For and for each. But basically, I just think it's clean. Still also not sure about type. Like, I could do I int or int I, or nothing. Oh, well, I guess, no, I said the types would be like implicit. Yeah, they'll be like assumed, so I guess for something like this you wouldn't even need a type. Alright. What was I doing? Floats and int. That's right. I mean, I guess I'll just create a new one. I don't know. I mean, it only has one element, and I'm not sure how many other, what other types of tokens would need to have the same sort of post-processing done, based on what they contain. Basically, I'll have it be token contains swap. It's a terrible name, I think, but whatever. Oh wait, it can't be a map because it needs to have the token, the character, and then the new token. I can use a tuple or a vector. I forget which one's more efficient, but whatever. If token type to new token type. My keyboard is not agreeing with me. So if token type const character. Oh wait, I can maybe do a pair. Wow, okay. I type on this keyboard every day and I am not doing well. That's a terrible way to do it, but I'm gonna do it anyway. Dot. Oh wait, no, I don't want it to contain a character. I want it to contain a string, technically. Not that I know if I'll ever use that. Okay, really? Token contains swap. So basically I want to check token contains swap at the end of the token creation process, which is end token right here. Okay, sure. So I'll do the statement if token contains swap dot find. What do I have it called? Token type. It's not equal to. Oh, and then those are two separate variables, token type and the actual token value itself. Let's see. The first element of the pair, right? Wait, what's the function for string contains? String dot find, I think. Yeah, it's a token content. Find, well, okay. I guess it'll just be single character. Yeah, I'm trying to think of, like, in the future, will I really ever need this again? Can't really think of another case where there might be a symbol inside of, like, the middle of a token, and then that sort of changes the type, other than for integers and floats. I guess I'll just make it work with single symbols for now, but, token content.find, token contain swap, token type. So that's the pair dot first is the token. Then I just want to change the token type. Okay. That took longer than it probably should have. Token contain swap, token type dot second. Alright, let's see if that works. Wait. Float. Yeah, okay, hold on. Number node? Nope. That didn't work. Wait, hold on, what? Oh, did I even recompile? I didn't, and there's an error. Once May 9th. Oh wait, that's the wrong file. I think I'll just make it not const. Assignment of read-only reference token type. Did I use the wrong variable? I might have. Token content current token. What is current token equal to? Oh man, I wrote this like yesterday. This is not good. Oh, it's current token. Yeah, I'm using the wrong thing. Not token type. Okay, see if that doesn't have any errors. Good. Let's run. No errors here either. 4.6 float node. And nope, the other integer is also a float node. That's not good. They should be integer nodes by default. First. Well, that's a character pointer, so I have to sort of set the... Okay, hold on. This system is currently a mess. Okay, am I failing to recompile, or is there some sort of error that I'm not familiar with? Because Yeah, it thinks those are floats for some reason. Okay. Oh, if I was checking to see if the character was inside of the string, but I wasn't making sure that it wasn't equal to the end, which is token content. No, it's std string end pause. Yeah, okay. So it was just returning true every single time for an integer or a float. Okay, so that's a float and that's an integer. Awesome, that is super cool. So basically, I think any operations that have a float need to have the integers converted to floats. I believe. I think that's how it should work, so that, you know, the float takes precedence, so its accuracy is not just removed. Yeah, but basically what I can start doing now that I actually have the types differentiated is I can create a expression evaluator, which basically looks at each of these expressions and then the two values beneath those and actually computes it if both of them are constant literals. Oh, you know, something that I kind of want to do with ASA is have it compile for the AstroSam. I don't really know if that will be an easy thing to do, but it is the CPU I'm technically most familiar with, oddly enough. Well, I mean, I did create it, but basically, my point is it would probably be easier to make it compile to that than any other CPU. And it would be worth it because, I mean, there is Gerard's language, Yabble, and I think Juke was working on a language at some point. But a lot of them are pretty, like, end of development. And I don't mean that in a good way, as in complete. I mean, they stopped working on them. And it would be nice to have something a little better, a little more, you know, rounded. And if I have a language that can cross-compile between different systems, I mean, I'd obviously want it to work for Linux. That's what I'm using. Well, I'm in WSL now, but it's basically Linux. But I also want it to work on Windows and basically make everything super easy and cohesive and, like, yeah. Alright, I'll stop ranting. Let's work on this expression evaluator. Integer, float, boolean, string. Right. And I also think I have those set. Integer, float, string. Alright. Optimize? Yeah. Optimize the function is right, and that's right. Node type. Do I have to call optimize AST node on each of these child nodes as well? I'm not exactly sure. Sorry if you hear loud sounds. There's a lot of traffic where I am. Let's see if... Oh, shoot. Oh, I was doing this wrong. Okay. I was kind of wondering why I had the node, but I want to check the first and second nodes. Yeah, okay. If, sorry, I was just checking YouTube again. Okay, so if the first node is a literal, then we want to get the value of it. Well, no, because... You know, it would be really nice if C++ had an easy way to have a multi-value variable. Well, I mean, I know that there are ways, like, I think boost has an any type. Yeah, but I think I basically just need to create them on my own. Yeah, so I'll just create... Okay, this is not good. There's probably a better way to do this. Basically what I'm thinking is... I have, you know, a bool, an int, and a float. Should I use float? I should probably use double, actually. Just... it's the highest... nice accuracy for them. And then... Oh, that's actually supposed to be an I, or an F, not an I. And then these first need to be second. Well, I guess I could use a pointer. Yeah, wait, no. How do I mean, I could have a pointer that just changes where it's pointing to between each of those three and then each of the second three, but I'm not sure how the C++ compiler checks for that. It might not allow that, so I might have to like use an int type as the pointer. Okay, so I was just looking into it. It might work, but says platform specific, so I guess we'll deal with that when it stops compiling for weird platforms. Well, can I define it as a pointer then? First val pointer. Dang it. Takes a while to save a file because it have an automatic formatter with Clang. For some reason it's pretty slow. Anyway, well, I should actually check my background processes. Alright, that might speed it up a bit. So if the first node is a literal, then I mean, I guess I have to manually check the types then, or maybe I can do a switch case, which is first node type. I don't know how many different types I'm going to be adding. I don't think I'm going to be adding like a char or well, many other types, because I mean the compiler can sort of assume what it is. Well, actually no, I probably want, yeah, the compiler should, the language, you should be able to define like an unsigned int 16 or something like that, and then the compiler will abide by that. Because otherwise it's using like full integers and things that don't really need to be used. So for optimization purposes, I will want to add more. Although I guess those can be added as like a subtype as part of the node instead of the main node type, because they will still fit into the category. Like an unsigned int32, that's still an int, so I don't need to, yeah, I don't need to add that as a full node type. So switch first node type case. Well, we'll do bool int and then float, yeah. And Boolean is just going to be treated as a 1 or 0. Yeah. First value pointer is equal to well, first B. Is equal to first, and then I have to do token value. I'm not really remembering my own standards. No, it's just token. And I'll do token is equal to true, 1, or no, true, because it's a bool, I just want it to be Oh, that's the wrong syntax. False. Forgetting my C++ as I make my own language. Not very good. And then for integer, first valid pointer is first I. First I. S2I. I think so. String to int. I don't know if any of you know, but I have not done much programming for the past 2 or so months. You can tell by my GitHub commit calendar thing. Doesn't have very many green squares. Is string to float a function? Probably is. Cannot convert bool pointer to int pointer. Yeah, I was afraid of that. Okay, the compiler really does not like that. Oh, wait, hold on. I think I can just do it if I... Yeah, if I, cast it as an int pointer. Awesome, that just works. So that's for first. I'm just repeating a ton of code here, but I guess if it's for only 2 elements, it's fine. Oh, this actually can't... Yeah, that's not supposed to be in here. I should do a check between... or for the second node separately. Okay, so now both those pointers will point to the actual value. And, let's see. on else, where they're not a literal, they should be an expression. No, they should be... It should check if it's an expression. And if it's an expression, then it will reevaluate it? No, because this works from the bottom up. Let's scratch that for now and just see if it works as it is. Alright, so if it's an operator and... Yeah, let both of those check to see if it's an operator. First, second. So if the first item is a literal and the second item is a literal, and only if both of them are, then we'll do, we'll evaluate the expression between them. Yeah. There is, like, there's that precedence that I talked about where, you know, if it's a float, then the output should be a float. Or is that how it should work? It should probably be like that until it reaches the set operator. Like, it'll do 4.6 plus 5, which is 9.6 times 1, you know, plus 2 minus 9, and it'll stay afloat all the way until it reaches I, in which case, if I is defined as an int, then it'll convert it to an int. But it won't do it anytime before then. It'll assume that it is a float. Okay. See, do I need to have... Probably want to have something to track the highest accuracy. Like Boolean and integer, those would have a accuracy level of like 0. And then float would be like 1. Well, and then I guess I don't really need much more than that. Oh, and then for... Yeah, for default, what I want to do is make sure that first is literal is then changed back to false, because it is possible for it to be a literal, but that literal could be a string, and you can't add an integer and a string together. That's not possible. First is literal, second is literal. Yeah, I'll need a second one of these for the output value. And then I guess for each of these, I can set the... Here, let's make sure that the output value is by default an integer, I guess. But then if either of them are a float, then it can be set to a float. Yeah, that sounds good. Pointer. What is the width of a double? Oh wait, no, that would only... I'm just not sure if the pointer would point to the beginning of a double or if there's like some byte offset. Whatever, I'll deal with it when we get there. Output F. I don't know, maybe I can have like a separate boolean to say that it's a float, or I could just check to see if the pointer is a float. That's probably the lazier method, but might work. Alright, the first is literal, second is literal, then I can do the operation between them. I think C++ will automatically work. Oh, but then I have to dereference the pointer and cast it as the correct type, don't I? Okay, this might be a little more difficult. Do output value pointer dereferenced. Although it's an int pointer, so it's gonna think it's an int. Unless I cast it, but that... okay, we'll do an if statement then to check if the output value pointer is equal to the int pointer cast of float. Bam. And if it is, then I'll know that I have to cast this as float pointer. No, I have to do that before dereferencing it. I think I made this more complicated for myself than I actually needed to. Yeah. Whatever. First val pointer. Dereferenced. Oh yeah, but then the type is... It assumes it's an integer. Oh, I'm killing myself. Not literally. I mean, this is killing me. I think I'll do integer first, just because it would probably be easier. So it's first val pointer times the dereference. Do I have to put parentheses around that? I don't know. Alright, that compiled, so I guess let's see if it actually does something. Oh, I don't actually use it. Hold on. What's this function called? Optimize AST node. Add that down here. AST nodes. Optimize AST node, and then I'll use the root node. Still compiles, that's good. Plus between 4.6 and 5, that well, it didn't do anything. Oh wait, I don't have it. I don't have it do anything. Yeah, that's right. Resistor resists charges, so is there that attracts charges? You know, that's a good question. I think that's like a wire. Yeah. And I'm making the compiler in C++, so it will be slower than C. Actually, I don't think there would be any speed difference, really. So only if both are literals, then it will actually evaluate. And then when it evaluates that, what I want it to actually do is remove the child nodes. I think. Yeah, okay. So I want to remove the child nodes, and then I also want to set its type equal to whatever type is used as the output value pointer. So I do node. What values are there that I should have? Well, I'll remove the child nodes first. Set the node type. So for in this case, that would be float type. So this node type would be integer node. Token type. Do I need that? Yeah, actually, I think I probably should. Integer. And then the token should be the string version of the output node, or the output value. And line numbers should remain the same. And leaf nodes is the same. Yeah, okay. Token value or token? Token, okay. I don't have a good naming convention, so... I think I can just do SED to string. Which can then take the value of the output value pointer. Okay, that compiled. That's kind of surprising to me. Expression term, expression plus. I don't think it's evaluating this because I don't think I have parentheses in the expression type. Let's see. So child node. Yeah, I think I need to add that. Oh no, it's an operator precedence, isn't it? For parentheses, currently the direct child node is of the type expression term, and I think that's probably wrong. I'm not entirely sure why that would prevent it from working though, because it goes through all of the children. Optimize AST node. Goes through each of those until it has no child nodes. Maybe I should do a check to see if the... Yeah, no, it's still not entirely clear. Maybe first is literal and second is literal is not even running. That is possible. Oh wait, it's supposed to be float. Yeah, let's also implement that for int, just because. Oh, and I'm multiplying these. It's not always a multiplication, but I guess I'll add in different operators later. Expression plus. That should be in the list for operator precedence. And it is. Where did the music go? Fix that. Oh, it's actually about to end. Find another video. All right. Sorry, I was looking at YouTube once again. Does that ever run? It's sort of odd. I'm gonna see if it ever runs. It doesn't seem to run. Well, I guess I'll leave that there until it actually does run. So if the child node's size is greater than or equal to 2. Okay, and then if the operator precedence of this specific node is not equal to ends, then that means it does exist. And I can look at the child nodes, the first and second child node. if the first node is a literal, and the second is a literal, look at the node type, and if the node type is equal to Boolean, integer, or float, then do that. Is default still run? Maybe I need to add in my break statements. And it did work. Okay, awesome. I was just being a little dumb and not using my switch cases correctly. Oh, that is incorrect. Okay. So it combined those correctly. That is awesome. What it didn't do correctly, though, is do the actual expression correctly. I mean, I know I had it as multiply, but 4.6 times 5 is not 16 trillion something. I must be dereferencing the pointers incorrectly, I suppose. Wow. Yeah. Very well. So it's an integer, string to int, and for float, string to float. Then do I have to do the types separately? That's kind of a pain. Okay. I guess I'll just have to manually check, like, if first node type is equal to that, if second is equal to that. Value pointer. I can't really tell where it's happening, so I'm going to print out here. No, the oh, what? I did compile that, didn't I? Combined. Oh, the value is that. Okay. First value pointer. Ah, I see. That's supposed to be for second. That's probably not the only issue. Let's see if it does anything though. No. I mean, maybe I could simplify this with like a template. I'm not sure how to do this. Output value pointers, I need that. Is it the setting of the value? Maybe it's the type that's not getting the full flows. Oh wait, can I use void pointer? I think I... okay. That's probably the correct thing to use, isn't it? Slipped my mind a little bit, huh? Do I have to still do casting for... No, I don't have to keep doing casting for void pointer, do I? Yeah. Why did I not think C++ had a built-in method of doing this? That's, You'll never guess how long I've been using this language for. Output val pointer is equal to that's dereference it. I don't know about the string conversions. That might mess it up a little bit. Because I don't know if it can... I don't know if it converts the type back. Yeah, I got errors. Void pointer is not a pointer to object type. Oh, it needs to be explicitly cast. For using? Alright, so in this case, it would be a float pointer. First value pointer would... Oh dang, that would also need to... Yeah. So I don't think it really solves my problem. It'll compile, but... Let's see what the output is. That is a slightly bigger number. Let's see. If it's a float, it's only accessing the first value then, if it's a float. Really? Okay, maybe that template function should be created. So there's the output type, there's the first value type, and then the second value type. It's going to be using pointers, so no return value. That was weird, it didn't type in the rest of the letters. So O. O output. And then how I want this to be used is probably in sort of like a switch case scenario. So instead of doing like if float and if int for the output value, it will handle that automatically. Oh, actually, no, it shouldn't handle that automatically. It should handle that after processing because it still needs to convert those into strings. Or no, it doesn't have to convert those into strings because I can have it return a string type. Yeah, that's how it should be. And then that way... Yeah. Oh no, because I still need to have the integer node and the integers. Okay. So yeah, I'll just have it post-process. It'll be easier that way. So I'll do evaluate expression. And can I have a type name variable? Like, type name, first type. Second type. And then output type. That way I don't need to like infer from the pointer type. I don't think I got an error for that specifically, so I think that'll work. And I'll assume that that's like int for all of them. Unless otherwise changed. Yeah. So first type. I know it says float node, but I'm going to make them all doubles. Oh, oops. I am not typing very well today. Alright, and then for this evaluate expression function, I pass the output type, and then the first type, and then second type, and hopefully those can be variables. I'm not entirely sure. Ooh, can you have types as variables? Ooh, no, it seems this was not going to be as easy as I hoped. Yeah, I'm reading up on it, and yeah. Oh well. mean, I can't just do... that's 773. Okay. Got it. Okay. I need to rethink how I'm going to do this now. There's no type. No. Okay. Let's rethink this. Yes, new programming language. Much wow. I went over what it was like towards the beginning of the stream if you wanna, I don't know, watch that part. Maybe I can still use the type, but use AST no types instead of, yeah, instead of type names. Oh, but then the templates still won't work. Yeah, because it needs to be a variable type. I'm not making this any easier for myself, am I? So if output type is equal to float node with that if. The output type, I should probably make that by default actually like nothing. Yeah, and then I can set it output type is equal to Boolean the first term is a Boolean, then it'll set the output as a Boolean, but if the second term is anything but a Boolean, it'll change it. And the output value pointer is by default int. Let's make it by default bool. And then I can change that to int as needed. Well, I guess it's just make each of these all the same. Makes it more readable. Not that this is readable. And then for the second node, I need to do similar. So if the first one... okay, so if the second value is a Boolean, let's see. I only want it to stay a Boolean if the previous term is a Boolean as well, so that means it would just stay the same then. And I want it to change to an integer if the second one is an integer, but only if it's not a float. So if output type is not equal to float node, because if it's a float, then I want to change it to a float. That's this Boolean. Output I. Just make sure all these are the correct types, because that's not going to be good if it's not. Alright, so now if the output type is a float node, set the node type to output type. Token type I'll just set back as number. Or wait, number doesn't exist anymore. I deleted that, didn't I? Oh no. I'll add that back in, but that will just be like a number that has already been computed. Which is probably not a good way to do it, but whatever. So token type is equal to number, and then the token is equal to the string value. Awesome. Now instead of doing this, what I want to do is create a string out string. and set it equal to that. No, actually, I want the out string to be defined out here. Alright, and then I can just move all of this down to the bottom. So it's a number. No, okay, that's the wrong way to do it. I shouldn't be using that. I can just do a simple switch case. So switch output type. Case integer node. Float node, and then Boolean node. Oops. I was saying bool. Wait, is there not a bool type? Oh, there's true and false literals. Okay. I guess we'll just leave it as an integer. Yeah, so if it's an integer or Boolean, then it'll just be an integer. Yeah, because I can just simplify bools as ints, that's fine. Alright, so then all of that is basically done. Oh, and then that needs to be set as the out string. Nice. Oh, I'm dereferencing these as floats when they're doubles. Oh, that's hilarious. Well, first of all, I'm doing string to float here. Is there a string to double? Okay, yeah, seems there's a string to double. Let's use that then. And let's also not mention floats, because that's a little ridiculous, you know? And then these just need to be int still. See if it even compiles. Integer, can I convert token type to AST node type? 773, 779. Oh, integer node. Wait, I have Boolean nodes. Why is that? Oh, I need to make them nothing nodes. Never mind. I think. Good enough. It compiles. That's good. and it runs. That is also very good. 4.6 plus 5. I mean, I haven't implemented expressions yet, but that's actually really good. It gave the correct value. It converted it into a double, and it set that as the string. That's genuinely awesome. We're like 90% of the way there then. So now I just need to actually add in the expressions. So let's, if node type, yeah. If float output int out, nope, output. And then I want to do like a switch case again. Based on the operator type. Yeah, so node type. Let's see, what are the operators? I'll do split. Okay. Times divided plus minus. Then the comparisons. Okay. I think the simplest way I can do this is... Genuinely not sure, actually. Comment that out. So here I set, the value. It's a float, but then it needs to be equal to the first value times the second value. Oh, the first value should change the value of the second value. And the second value should change the value of the first value if it's equal to a float. Okay, so let's do like an if up here. If either of them is a float, then the other needs to be changed to a float. Yeah, okay. First type is equal to float node or type. Wait, I can just check if the output type is float. Yeah, because if the output is a float, then that means one of them is a float automatically. Then I can do an if for each of those. So if first type is not equal to float, then I want to do well, first I need to set its type equal to float. And then first value. First value pointer. first f is then equal to dereference the first value pointer let's just do it like one at a time, and then I convert to a double for first value pointer. So instead of if not equal to float node, I'll do if equal to Boolean node. Yeah, that should work. And then I have to do it for the other types, which is annoying, but whatever. And then for the second type, Boolean. Okay. So for times, I can just multiply them now because they're already doubles. That's kind of unreadable syntax, but whatever. I need to change the width of this. No, that is... What? Is it width? Okay, I don't know the command for changing the width of a split. I can only change the height. Res width is it like W res equals 15. Res W 15. Ah, that sucks. Whatever. I'll deal with it. Alright, times, then we can do expression divided. I wish there was a better way to do this. I mean, there probably is, but I've said that a lot of times on this screen. Expression plus. Minus. And if the output type is a float, then I don't need to do any of the comparison operators. Yeah, that seems good to me. So now we can test to see if that works. It doesn't even compile. Okay. Invalid argument of unary times. Oh, those are supposed to be pointer types. Yeah. It'd be a bool pointer and an int pointer. So it should not be a 4.6 anymore. It should be a 4.6 plus 5, so 9.6. It runs 9.2. What? Okay. It's a plus. Should be double. Is it in the casting? It might be in the casting. I might want to try casting it correctly. Static cast. For dereferencing an integer. Okay. Static cast to double. That's right. Oh, I have to move this cast as well. $9.2. Why is it? Huh. Okay. Really? Let's see if I can just check what 5 is being evaluated as. Wait, hold on. Did I recompile? Yeah, I think I recompiled. Never mind. So if I do 0.0, right? So 0.0 plus 5 is evaluating to 0. Okay. 1.0 plus 5? It's 2. Huh. Let's make it like 1.2. Okay. 1.2 plus 5 is 2.4 now. Let's see what I'm doing wrong. So that is a double pointer, first val pointer. Oh, I'm not changing the pointer, am I? Got it, okay. I was wondering, because it was adding an int type, so it wasn't converted into a double. So I need to do first val pointer is equal to first f. Okay, now it should work. 2.4. Nope. Did I compile? I did. Still 2.4. Why is it? Did I save? Yeah. Huh. Oh. The operator was operating on itself. I think I need sleep. It was doing first val pointer times or divide by or plus first, so that's not good. Okay, now it should work. Files runs, and it's 1.2 plus 5. Okay, that plus 5 is now not working. I'm not even gonna say it. There's more first things that I did not change to seconds. What? Okay, that's still 1.2. Still 1.2. Did I compile? Okay. Still 1.2. Let's maybe try not evaluating the expression, but like keeping it as sort of a keeping it as a float, I guess. But I think this will still remove it. Yeah, it does. reference double pointer for the second value and the first value. Okay, I'm genuinely not sure why 5 is being overwritten. I don't think its type is being changed up here. So that would be second type. So it's of type integer. And if output type is not equal to float node, then it's set equal to integer node. Okay. I'll look for any wrong first words and any wrong second words. Looks good to me. Second eye, seems that. And after that, check if the output type is a float, and it will be. First type is a boolean. And it's not, so I shouldn't do that. Second type will be an integer, so I changed its type to float. Set the float value equal to the cast value. Okay, so if I don't cast, it gives no error. And still does nothing. Okay. I'm just adding parentheses to make sure all these terms are executed correctly, individually. I mean, one easy thing I could do is just output app. So I guess I don't really need to use a pointer if I'm already separating everything manually anyway. I mean, I can use the pointer for output, obviously. .2 still. Okay, that's... I mean, that's annoying. What happens if I make it swapped, so it floats on the other side? .2. So it... Okay, so it, like, prefers the float. Yeah. So that means it has to be happening when it's casting? Dang, this is, still 5.2. Alpha type is float node. Both of them should be converted to doubles at this point. You know, I've probably been streaming for too long. Well, I guess it's only been 2 hours and 52 minutes, but... Oh, you can probably hear my dog barking. Anyway, That's probably good for the stream today. I'll definitely solve this in the next 5 minutes after ending the stream. But thanks for being here. I won't be streaming tomorrow, but I might be streaming on Monday at about the same time. Yeah. Bye, everyone.